Hi everyone, Dankman here. So I'm doing another example for solving equations by elimination, but this is going to be something a little bit different, brand new, that we'll go into more detail with tomorrow. So, here's what I've got. I've got two equations. It's a system of equations. The instructions are going to be to solve this system of equations. I'm going to try it by elimination, because that's a method or a technique that we're learning. And I'm going to go set it up, therefore, and I'm going to say, okay, I'll take the top equation here, 2x plus 8y equals 20, and I'll draw my golden road, all right? And I'm going to take that second equation here now, and I wanted to go ahead and add the second equation to the first equation, because that's what we've been doing in an attempt to eliminate one of the variables. But you can see that if I go forth with adding, right? So I'm going to just do this on the side really quickly. You don't have to copy this down. If I add 2x plus 8y equals 20 and 2x plus 6y equals 14, if I add those two equations together, I get 4x plus 14y is equal to 34. And this new equation is a cool equation. Looks pretty cool to me, but it hasn't eliminated a variable. It hasn't created a single variable equation for me, which of course was the entire point. So our first sort of hiccup or issue with this type of method, since we started it yesterday, is that if I just go blindly adding these two equations together, they're not going to magically eliminate one variable. However, you'll notice that the two x terms in the equations are the same, which means that instead of adding, if I chose to subtract the bottom equation from the top equation, I'll get 2x minus 2x, and 2x minus 2x is 0. Now, if I start subtracting here, I have to subtract all the way across. So now, instead of adding the same thing to the left side and adding the same thing to the right side, I'm actually going to subtract the same thing from both sides. Same principle, that as long as you do the same operation to the left side of the equal sign and to the right side of the equal sign, you produce an equivalent equation below and you don't change the solution. But instead of adding this blue equation now, we're going to do 2x minus 2x, which means we also have to subtract 6y, and we also have to subtract 14. And so to make that really clear, I'm going to put this whole thing in parentheses here. I'm subtracting this entire equation. So now it's 2x minus 2x and 8y minus 6y, which gives me only 2y, and then 20 minus 14, which gives me only 6. So 2y equals 6. Now to just review this one more time, if I go adding the top equation and the bottom equation, it looks like what I wrote up here in red, 2x plus 2x, 8y plus 6y, and so I don't end up eliminating a variable, but I recognize that if I could subtract the blue equation from the black equation instead of adding, that would eliminate one variable. So to do that, I'm going to show myself with my golden road and everything. I'm going to line everything up, and I'm going to show myself, look, I'm subtracting everything in these parentheses. So I'm really subtracting the left half of this equation from the left half of my original equation, and I'm subtracting the right half of this equation from the right half of the first equation as well. So I put it in parentheses to show that I'm basically subtracting everything in the parentheses, or distributing this negative sign to everything in the parentheses. Alrighty? Now I'm going to finish up. Divide both sides by 2 to get y equals 3. And since this is a system of equations with two variables, we are not done yet because we've only found a solution to one of the variables, and the full solution will be an ordered pair. So I'll pick an equation. It doesn't actually matter which equation, because what I'm going to do is I'm going to take my solution for y, I'm going to substitute in 3 for y, and that has now created a single variable equation, 2x plus 24 equals 20. So I used to have the letter y and the letter x in that equation, but now instead of two different variables, I've converted this equation into a single variable equation, and we know how to solve single variable equations in our algebra class. Stack our equal signs on top of each other, carefully and strategically do the same operation to both sides, producing equivalent equations until we have a solution. So my solution here should be -2, 3. That's an ordered pair. That should solve both equations. Let's check. 2x plus 8y equals 20. 2x plus 6y equals 14. If we did a good job and made no mistakes, then when I take this solution and I plug it into the top equation, -2 for x and 3 for y, it looks like this down here. -2 replaces x, 3 replaces y. I get -4 plus 24 equals 20. And indeed, that is a true thing. Next, I will take -2 and substitute for x, and 3 and substitute that for y in the other equation. I will multiply to get -4 plus 18, and I will add -4 plus 18 to get 14. That is a true fact as well. And so, we've now seen our second example of this elimination method, and a special case now that we'll go into more in depth tomorrow.